Good day and welcome to One-on-One Maths Private Tutors. Today we are looking at O-Level and IGCSE Mathematics for ZIMSEC and Cambridge. We continue with the topic trigonometry. Let's look at the general formula for the area of any triangle. So if you have a triangle and you know two adjacent sides, A and B, and the angle that is included, theta, we can say area is equal to half A times B sine the included angle, theta. So the angle has to be between the adjacent sides. So let's look at this diagram. If we have angles A, B, and C with sides A, B, and C, we can say area is equal to half A, B sine C, which is the same as half BC sine A, which is equal to AC sine the included angle B. So this is how we find area of a triangle for any type of triangle. Let's look at this example. Find the area of the triangle shown. So area, we are given this side and that side. So we can say half times 13.1 times 12.4 sine included angle 101. So on our calculator, we say fraction, then 1/2 out of the fraction times 13.1 times 12.4 sine 101 close bracket equals 79.7 square centimeters to 1 decimal place. Finding lengths and angles in 3 dimensions. You can find lengths and angles of 3-dimensional objects by identifying right-angled triangle within the object and using Pythagoras theorem or trigonometry. Let's look at this question. A rectangular box measures 4 centimeters by 3 centimeters by 6 centimeters. Calculate these. AC. So AC is this diagonal there on the base rectangle. So if we take this rectangle, A, B, C, it is a right angled B, and AB is 3 centimeters, BC is 6 centimeters. Now to find AC, we can use Pythagoras theorem. AC squared is equal to 3 squared plus 6 squared. AC is equal to the square root of 3 squared plus 6 squared, which is equal to 3√5 or 6.7 centimeters to 1 decimal place. So we can say it is equal to 6.7 centimeters to 1 decimal place. AR, which is here, A to R, is on triangle ACR, which has a right angle at C. So if we have triangle ACR, AC is 6.7, CR is the height here, which is the same as AP, which is 4, and a right angle at C. AR is the hypotenuse, so AR squared is equal to 6.7 squared plus 4 squared. AR is equal to the square root of 6.7 squared plus 4 squared, which is 7.8 centimeters. Another way to find AR, we have AB, BC, and CR. And we are looking for AR. AB is 3, BC is 6, CR is 4. So AR squared is equal to 3 squared plus 6 squared plus 4 squared. That is for the diagonal of a rectangular prism. This long diagonal from this corner to that corner, we consider the length, width, and height. And we can use this formula, which is similar to Pythagoras theorem. Then our AR will be equal to the square root of 3 squared plus 6 squared plus 4 squared. Using our calculator, square root of 3 squared plus 6 squared plus 4 squared will give us root 61, which is 7.8, which is the same as what we found there, 7.8. Angle RBC, angle RBC. So we have this triangle, R there, B there, C. So this is the angle we are looking for. And we are given this side BC is 6 centimeters and RC is the same as PA, which is 4 centimeters. Now, considering this angle, let's call it theta, we have opposite and adjacent. And from our SOHCAHTOA, if we have opposite and adjacent, we can use tan. So we can say tan theta or tan RBC is equal to opposite 4 over adjacent 6. RBC is equal to arctan 4 over 6, which we can find from our calculator as shift arctan fraction 4 over 6 close bracket equals 33.7 degrees to 1 decimal place. Always show your accuracy. Angle ARC. Now we have the triangle ARC, so we want this angle ARC. Considering this angle, we have opposite and adjacent. This is ARC, so this is the angle we are looking for. We have the triangle there with opposite and adjacent. So we can say tan ARC is equal to opposite is 6.7 over the adjacent to the angle 4, giving us ARC as arctan 6.7 over 4. From our calculator, we get shift arctan fraction 6.7 over 4, close our bracket, equals 59.2 degrees to 1 decimal place. 59.2 degrees to 1 decimal place. So that is our answer there. Let's move on. Let's look at this example. Find the length of the diagonal of this cuboid. Let's call it x. So we can say, using our equation, x squared is equal to 5 squared plus 2 squared plus 3 squared. Therefore, x is equal to square root of 5 squared plus 2 squared plus 3 squared, which we can get on our calculator. Square root of 5 squared plus 2 squared plus 3 squared, which is root 38, which is 6.2 centimeters to 1 decimal place. Let's look at this question. A tree, TC, is 20 meters north of point A. 20 meters in the northern direction. The angle of elevation of the top of the tree, T, from A is 35 degrees. The point B is 30 meters east of point A. A, B, and C are on horizontal ground. Calculate the height of the tree. So let's consider triangle ACT, and we can see the angle at C is a right angle, and then the T is there, and A. So here we have 35 degrees. CA is 20 meters. So we want the height of the tree. We can call it X. Now, considering this angle, we have adjacent, and we want to find the opposite. So we use tan. Tan 35 is equal to opposite over adjacent. Opposite is this, X over adjacent is 20. So by making X subject of the formula, we'll have X is equal to 20 tan 35, which we can get from our calculator as 14.0 meters to 1 decimal place. The length of BC. Now, if we consider triangle ABC, since this is north and this is east, the angle between AC and BC is 90 degrees. So we have ABC with, since this is north and this is east, the angle between AB and AC is 90 degrees. Now let's look at the length. We have 30 meters from A to B and 20 meters from A to C. So we have 30 here, we have 20 there. So to get BC, we can use Pythagoras theorem. BC is a hypotenuse, so we can say BC squared is equal to AB squared, which is 30 squared, plus AC squared, which is 20 squared. BC will be equal to the square root of 30 squared plus 20 squared. On our calculator, we can say square root of 30 squared plus 20 squared, which will give us 36.1 meters to 1 decimal place. Angle of elevation of T from B. So we want the angle of elevation of T from B. So we consider triangle BCT with B there, C there, and T. This angle will be right angle since these are on horizontal ground and T is vertically above C. So the angle we are looking for is this angle of elevation. We can call it theta. BC, we have just calculated BC as 36.1 meters and TC as 14 meters here. So we have opposite and adjacent to the angle in question. So using our trigonometric ratios, we have opposite and adjacent. We can use tan. So we say tan theta, which is our angle of elevation, is equal to 14 opposite over adjacent 36.1. Theta is equal to arctan 14 over 36.1. On our calculator, we use shift, arctan, and fraction 14 over 36.1. Then we move out, then close the bracket, equals 21.2 degrees to 1 decimal place. And that is our answer. Okay, let's look at this question. A mast MG is 50 meters high. So MG, this is a mast 50 meters high. It is supported by 2 ropes, AM and BM. Other measurements are shown on the diagram. Is the mast vertical? Okay, is this a vertical mast? So let's consider triangles and see if they are forming right-angled triangles. Let's consider triangle MGB. Now, for the mast to be vertical, this angle must be 90 degrees. So if we have 50 meters there and 50 meters there and 70 meters, the square of the hypotenuse, which is 70 squared, should be equal to the sum of the squares of the two other sides, 50 squared plus 50 squared. Now, 70 squared is equal to 4,900. And 50 squared plus 50 squared is equal to 5,000. So 4,900 is not equal to 5,000. So this mast can never be vertical because Pythagoras' theorem is not followed. The mast is leaning at some angle from the horizontal ground. Also, if we consider AMG, this angle is 38.7. M is here, and G is there. We have 80 here, we have 50 there. MG is 50. Now, for it to be a right-angled triangle, we have opposite and hypotenuse. So using our trig ratios, opposite and hypotenuse is sine. Sine 38.7 should be equal to opposite, which is 50, over hypotenuse, which is 80. Now, if we calculate sine 38.7, we will get 0.6252. This should be equal to 50 over 80. Let's calculate 50 over 80. 50 over 80 is equal to exactly 0.625. Now, these two numbers are not equal, so the mast is not vertical. Thank you.